Hey everybody, my name is Dan, and today I'm going to be talking to you about how to connect SNS to Lambda in AWS. So as a little bit of an overview, I have this little section in the bottom right here so you can follow along. So first we're going to start with a little bit of an app overview. So this is kind of my hypothetical application, so we're going to talk a little bit about how it's going to work. Then I'm going to talk quickly about what SNS is, why it's useful, why you want to use it. From there, we're going to quickly review Lambdas, why they're useful, why you want to use it. And finally, we're going to actually make the thing. So let's start with taking a little tour of this hypothetical application here. So in this app, I'm basically framing it as a payment processing application. So you may have customers that are purchasing something on some application, and you have these events that are flying through there. Maybe they're kind of refund events, maybe they're purchase events. These are the kind of things that we're going to be processing here. So in this example, we have this computer here kind of represents a web server that, it could be field requests from clients coming out from this direction. Could be, mobile applications, could be browsers that are kind of invoking these back-end APIs. From there, this web server application is going to push a event into an SNS topic, and that topic is going to be called a transaction topic for this exercise. From there, we are going to invoke a Lambda based on the event being published to the SNS topic. And this Lambda is going to be called a payment processor. And the payment processor is going to be fairly simple. All it's going to do is basically log the contents of the event. And that's going to be done through the handler here. So moving on to number 2, a little bit about SNS, why it's useful. So SNS stands for Simple Notification Service. It's actually really useful for fan-out types of applications. So what do I mean by fan-out? So you can have multiple clients that are pushing messages into the topic. And the real strength of SNS is multiple listeners can be notified of when a message arrives at this topic. So in this example, we just have one. We just have this Lambda that we're creating, right? And we have a payment processor. In a little bit more rich architecture, you would have multiple listeners here. So you could have a separate application, maybe a box over here that could be an SQS queue, where you have another application or another feature that is listening to these events and may want to process these messages in a slightly different way. So that's the basic idea here, right? You have messages being broadcasted to this SNS topic, and you can have multiple clients that are listening and processing these events, and they're all in isolation of one another. So over here, I just had some separate examples here of kind of things that can trigger a message being pushed to an SNS topic. So say you have a S3 bucket, and you want a event to be triggered to your SNS topic whenever someone uploads something to this S3 topic, or S3 bucket rather. So you can actually wire an S3 put to an SNS topic and trigger a Lambda that way. There's other options here. You can have a DynamoDB table. Whenever something happens on the table, you can trigger an SNS topic, and then that goes to your Lambda as well. So there's really a ton of a variety here of things that you can use to invoke this Lambda, push messages to this SNS topic, which in this case is going to be invoking a Lambda. But really, the options are pretty endless here. So moving on to Lambdas. So why are Lambdas useful? So in traditional applications back 10 years ago, we didn't really have this concept of cloud computing. Everything was basically on a web server that was hosting a endpoint, and you had to pay for the resources, you had to buy the hardware in order to kind of host your web application. But the days of that are they're slowly going into the past. We're really moving towards this world where you don't really need to worry about buying hardware anymore or caring about web servers or anything like that. Another thing with Lambda, it really helps you out with concurrency. So you don't have to necessarily worry about browning out your web application that's hosted on, say, an EC2 machine if it gets too many concurrent requests. These things can scale up or down pretty infinitely. There's additional costs here that you need to be aware of. But there's flexibility here, and that's really what Lambda offers you. It's flexibility. When push comes to shove, it may be a little bit cheaper depending on your use case to actually go with buying your hardware and hosting your machine. But there's startup costs there, right? So you have to buy that stuff, put it all together, set up an environment. With Lambdas here in an AWS ecosystem, you don't really have to worry about any of that. All right, so back to this applications here. So just a quick overview. So we're going to have a hypothetical kind of EC2 or whatever here that's pushing a message to an SNS topic. It's going to be called transaction topic. That is going to trigger a Lambda, which will be invoked every time a message arrives at this topic. And then we're going to have a handler here that actually kind of handles that message and logs that information. So I'm going to go over here to my AWS account. I'm going to sign in. And the first thing I'm going to do is make sure I'm in the right region. So we're in US East 1. That's great. We're going to go over here and type in SNS. And here you see simple notification service, which is the stack that, or sorry, which is the service that we want. So I click there. And from here, there should be a section. Actually, they changed this recently. So I think they're actually asking you to create a topic right here. So let's actually click that. Yeah, there we go. So we're actually creating a topic from that kind of bizarre UI. So what did I say that original name was? I think it was, yes, transaction topic. So we're going to actually name this transaction topic. Display name, this is just kind of an alias that you can give it, kind of to group your elements together a little bit easier. Maybe like you have a pseudonym or something here that you kind of want to give to this topic. Encryption here, so it really depends on your use case. So encryption, if you have some highly sensitive customer data, in this case we actually theoretically do. We have potentially customer information that's coming through the wire here. What encryption allows you to do is encrypt the contents of your messages over the wire. And depending on your use case, again, you may want to actually use this. Personally, I've never used it, probably don't need to, but if you're dealing with highly sensitive data, maybe a good idea. Access policy, so this is actually kind of useful, but it really depends. If you're kind of in an environment where you have other teams that you're working with, and you often, like one team owns an AWS account, a separate team owns an AWS account, you don't necessarily always want to go back and forth and say, hey, can you give me the permission to subscribe to this topic? Can you give me the subscription to unsubscribe? It's really a pain in the butt. So what this section allows you to do is it allows you to specify things like, only specified accounts can get access to certain permission sets that allow you to allow them to perform certain actions on your SNS topic. So subscribe themselves, unsubscribe themselves, blah, 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 blah. We're not going to be using that here, just kind of doing a little bit of an overview here. Retry policy. Okay, this one is actually kind of important. So the way SNS works by default is that it comes with this default retry policy, which is 3 retries. This basically means that if you hook up a trigger to your SNS topic, if it fails after 3 times, this message will be lost forever, right? So take a second to understand that, because that's important. Depending on your endpoint, in this case we're going to have a Lambda. We're going to be using the concept of a DLQ, stands for dead letter queue. And if the SNS topic cannot deliver the message successfully without throwing an exception on the Lambda side, those messages will go into this DLQ. So it's basically like a record keeping area. And in the DLQ, it'll have all the messages that failed. And at some point later, you can visit that queue and redrive those messages manually. You may actually want to set an alarm on it to be notified if there's any production level impact to all these failures occurring. So in this case, I'm not going to really dwell on this too much. I would suggest leaving this default unless you really know what you're doing. And that's exactly what I'm going to do here. Delivery status logging. So this is actually a new feature. I don't really know too much about it. Haven't fully tried it. But I can tell you why they added this. And the reason is because when you're delivering an SNS message to some other endpoint, it's really hard to know if it actually got there. There's nothing that was previously telling you whether or not it successfully delivered a specific message. So I kind of suspect that this is why they added this feature here, so that there's some kind of audit log to make sure that if someone pushed a message to a topic, it actually landed on the other side. Keep in mind here, there's going to be extra costs. So this is going to add logging, and that's going to be by default going to your CloudWatch logs. Keep in mind, I can't remember the exact cost for CloudWatch, but I believe it's on the GB level. So make sure that if you add this, you are cognizant of the fact that you're going to be incurring some extra costs here. And they actually give you some ways to kind of reduce the cost here by selecting a sample rate. Maybe you only want to know about 1%, just to kind of get an idea of whether or not your messages are being delivered successfully. And tags, I don't really use this, but this again allows you to group your stuff together a little bit easier. If you have like one application and you have multiple resources that are related to the application, you can use the same tag for all of them to try and group them into one thing, and then kind of look at all those resources at once. Yeah, so I think that kind of covers all the main pieces here. Again, so topic name, display name, encryption, don't really need to worry about it unless you're using highly sensitive data. Access policy, this is more for permission sets for sister teams, sister accounts. Retry policy, the only really kind of important thing here is this. In general, you just want to keep this as the default settings. Status logging, basically delivery confirmation and logging on that level. Tags, basically a grouping mechanism. Okay, so from there, we're going to click Create Topic. And boom, topic is created. So what the hell are we looking at here? So we are faced with some basic information about the SNS topic. We have our name here. We have the account ID owner. That's my account ID. Cool. And we have the ARN. I believe ARN stands for Amazon Resource Name. It is the unique identifier for this particular AWS resource. So this is a unique key. No one else will have this. This is yours. And this is how you can kind of reference this SNS topic from other sections of AWS. And from there in this SNS topic, the one thing you'll see that's kind of different from the creation step is this concept of subscriptions. So we actually don't have any subscriptions yet. We just created this SNS topic. We don't have a Lambda yet. So there's nothing to subscribe to. So what we're going to be doing next is we're going to be actually going to create the Lambda. And then from the Lambda side, we're going to be adding the subscription. All right, so let's go over to Lambda and create the Lambda function for this, and then we're going to wire everything together. Okay, if this ever wants to work, that'd be fantastic. All right, all it needed was a little push. Okay, we're over here in AWS Lambda, awesome. So we're going to start by creating a function. I'm actually going to be using a blueprint here just because it makes my life a lot easier. It kind of gives you the boilerplate so you don't really have to worry about it. And we're going to be using Python 2.7 for this. So I'm just going to come over here. I'm going to type in SNS to filter down all the garbage I don't want. And when you come over here, you see a boilerplate blueprint for SNS message in Python. So we're going to click on this guy. And this basically will fill out some of the details for you in terms of the code itself. So you see down here, this is basically the code that's going to be run every time a message is delivered to this topic. So let's go back here. And I think, what did I call this thing originally? I called this payment processor. So that's what we're going to name this. Payments processor. All right, let's go through each of these things here and describe what's useless and what you actually need to worry about. So execution role. Roles, a whole separate topic, but basically if this Lambda needs special permissions, for instance, say you want to write to DynamoDB from this Lambda, you may need a specific role in order to do that. And you can either create one that has the permissions, or you can choose an existing one. This Lambda isn't going to actually do anything like that, so we don't necessarily need to set up a new role here. So I'm just going to, create a new role with basic Lambda permissions. I don't really care. This may be more useful for you if you want to lock down your permissions. It's always a good idea to use the least permissions model. So don't just go out and give people global access to an entire AWS account. Always give resources only the permissions that they need. Okay, so now this is actually asking us if we want to trigger, and this is what we created in the previous step here. So AWS is smart enough to know that you have candidates for triggers in your SNS area. So it's just basically pre-populating it with this SNS topic ARN. So if you had multiple of these, say we had like 4 or 5 SNS topics, there'd probably be a drop-down list here and you can pick which one you want. But since we only have one, it's likely just defaulting to this. And then we also have the option to enable the trigger right now or not. The use case for not enabling it right now is kind of like you just want to set this thing up and see if it works and then enable it at a later time so you don't impact any production level stuff. For me, I don't really care. This is in production, so it doesn't really matter. So I'm just going to enable this right now. Going down to the actual code. So I'm basically just going to leave this as it is. This is a very, very basic Lambda function that just takes an event. The event is going to be the source. So, if you're pushing a message to your SNS topic that says transaction ID 123 purchase, maybe it was a purchase type of transaction, and maybe the value amount was $10. All of that content would be inside the event object, and you can kind of parse that out of the event object, which is kind of what they're doing here. Context, not going to go into it, gives you more details of the context of the invocation. So things like the AWS request ID, timestamp, stuff like that. You generally don't need to worry about it unless you actually need something specific from the AWS context, in which case I would suggest to go out and actually read the documentation to see how this works and if it can provide you with what you need. From there, there's really not that much to it. So we're going to create the function. And while that spins, we're just going to go back to our architecture diagram here, just to overview what we just did. So we just created a transaction topic in SNS. We created a Lambda payment processor. And while we were creating the Lambda payment processor, we hooked up a trigger. And trigger is kind of this linking line right here. So again, when anyone pushes a message to this SNS topic, that's going to automatically cause SNS to invoke asynchronously this Lambda handler. So let's go back here. And before I actually just test this out and verify and prove to you that it's actually working, I just want to take a few minutes to talk about some of the settings here. So since we did this in Python, we actually have the opportunity to use, I think this thing is called CodeStar, but it's basically an IDE in your browser. If you're using compiled languages like Java, then you're going to have to use a slightly different approach where you upload your jar file to S3 and then reference the handler in kind of this text. Not going to go into that, but I'll probably make another video for that at some point later. So if you wanted to kind of make changes here, you're totally free to. You can add extra print lines, you can add your core logic here, and then once you do, there'll be a button. This button here, save, will light up. You just save it, and then that's your new Lambda function. It's everything that you just put in there is going to be the code that's run at runtime. From there, we have environment variables. Variables are kind of useful. They're kind of global variables that are accessible from the context of your application. It's difficult to describe use cases when these are useful, but they do have their applications. I'm not going to get into when and why. Kind of like if you need global variables, would be the place to do it. Tags, this is the same as previous. I'm actually going to remove this because I don't want tags. This kind of gives you the opportunity to tag your resources for an application so that you can group them all together and look at all this stuff all at once. The execution role, so again, we were talking about the role previously. The role is just the permission set that this Lambda has, and I actually created one when I was setting it up, so doesn't really, this role means absolutely nothing. I actually want to talk about basic settings here. So this one is actually kind of important because this actually has a direct impact on your costs and how much you pay. So the basic idea of the Lambda function is that you can specify the amount of memory that you want your Lambda function to use. So it starts at 128 and it goes all the way up to whatever that is, 3008. So the cost structure of Lambda functions is such that the higher the memory that you specify on this slider, the more expensive your invocation is going to be. right? So, and that logically makes sense. If you need more memory for your application, some machine somewhere is going to have to field that request and reserve this amount of memory for you. So that doesn't come for free. I mean, Amazon has to pay for that, right? They have to reserve that for you. And that's why it's factored into the cost structure. The other element of the cost structure is number of invocations. So it's basically number of invocations. It's kind of a ballpark formula, but number of invocations times your memory usage times the duration of the invocation. So all three factors come into play when determining how much you're going to be charged. So it starts out as default as 128. Often this actually isn't the setting that you want unless you have like a very simple application like we have here where it's like literally 5 lines. And I would encourage you to start at the lowest level here and kind of dial it up slowly and see if you can find a balance between performance and memory usage. You don't want to be kind of hitting the ceiling of your memory usage because then you're going to get out of memory errors. But you also don't want to go too far in this direction, so you'll be paying a ridiculous amount for every invocation. So there's a fine balance here. So just do the exercise of trying this out at multiple ticks here and see what the performance of your application is and how much memory you're actually using. From there's a timeout. So timeouts are useful if you don't want your application to basically run for too long. So here, I mean, this is a simple application, so a 3-second timeout is totally fine. I believe this thing actually goes up to like 10 minutes now. Previously it was 5. But you have the opportunity to set this as whatever you want. So if your Lambda gets invoked, takes too long to run, in this case 3 seconds, it'll just kind of abort and you'll get an exception in your CloudWatch logs. Networking, VPC, not really going to go into this. This is more kind of a separate topic that we don't really want to talk about in this video. Probably make another video on VPCs and how to set that all up. Debugging and error handling. Okay, DLQ. This is actually probably the second most important portion of this of these settings. So the DLQ is very useful to handle processing failures. So on the SNS side, if you recall to when we actually created the topic, we set the retry policy to 3. That means that if we publish the message to our SNS topic and resulted in our Lambda being invoked, if the Lambda failed or threw an exception due to out of memory or maybe some dependency that it couldn't call, then SNS would automatically try to redeliver that message. And it'll redeliver that message up to 3 times. After the 3rd time, that message will fail permanently. And the functionality here is that if you don't have a DLQ set up, that message is lost. You'll never know about it. You'll never be able to recover it. So what DLQ allows you to do, and again, DLQ stands for dead letter queue, it allows you to wire the failures into a simple queue service. So what this basically does is if you have 3 failures, the content of the message will actually move into this queue that you can define. I don't have one here for this account, obviously. And so what this allows you to do is kind of recover those messages at a later point in time and redrive them back into this Lambda. And this is extremely important for failure recovery. So if you're using like a tier 1 critical application that needs to recover in the case of dependency outages, this is very, very important. And I highly encourage you to set up an alarm to page you or kind of send you an email anytime messages grow in this queue. Obviously, this depends on your application. If it's super important, then you need kind of alarms on this. If it's just kind of some Mickey Mouse application or you're just testing something out, then this is obviously overkill. But something very, very important to be aware of here is this DLQ component. XRay, this thing I've used in the past, it basically is a profiling service of your Lambda. Often it's hard to figure out what's taking so long in your Lambda. And since you're being charged by the second or a millisecond, whatever their cost structure is, you want to be able to isolate where things are taking too long and be able to optimize them. So what XRay does is it allows you to see where in your Lambda things are taking long. Say maybe it's a Dynamo call or an S3 put or something like that. Okay, moving down to concurrency. Okay, so this is actually kind of an important one as well, especially for those of you that have AWS accounts that have multiple Lambda functions in it. So the way concurrency works is that you have a by default concurrency limit of 1,000. That's your default, when you create an AWS account. And what concurrency in this context means is that you can have 1,000 concurrent invocations of Lambdas at any point in time. And that's shared across multiple Lambda functions in the same account. So say, for instance, you had 5 Lambda functions. Each of those can theoretically, say they were all processing the same message source, can process 200 messages at the same time. Anything over 200 each, so if you start to go to 1,001 invocations at once, that one invocation that's over 1,000 will get throttled, and it'll have to retry at a later point in time. So the reason this is important is because you can actually have Lambdas that kind of are very hungry for resources and can consume all the concurrency in your account, which will lead to other Lambdas that are also in your account to suddenly get throttled. So in this case, what this setting is actually asking you is, do I want this Lambda to use that pool? And that pool, every Lambda in this account will compete for resources in that pool. So that's an option. Like you have you have to make the decision on whether or not you want that. The other setting here is reserve concurrency. So this means that regardless of how many invocations are coming into this Lambda at any point in time, I always want to reserve, say, 100 out of my 1,000 for this specific Lambda function. So you can see when I put that 100 in here, the remainder pool of the resources that every other Lambda in this account will use is now 900. So everyone else is going to be fighting for these resources. So why is this important? Say this is like some kind of mission critical application where I never want this to get throttled. I never want it to slow down. I always want it to get invoked as fast as possible. You'll come here and you'll set this reserve concurrency to a reasonable number depending on your traffic patterns. And you'd have to look at your traffic patterns to figure out what a good number is here. So this is something that I'm not going to be setting right now, but it's very, very important to be aware of how this works and how this will kind of manifest itself in like throttling exceptions in your application if you're not careful. So I think I basically covered everything about this Lambda function here and how all these settings work. So let's actually go back to our SNS, and we're just going to publish a fake message to it, and then check the logs to make sure that it actually hit that Lambda function. So I went back to SNS here, I went to topics, and if I click on this topic that we created previously, now you can see we actually have a subscription. Remember, we never had this before, and it only became present after we created the Lambda and selected that trigger when we created that Lambda. So now we have this subscription here, so that's awesome. Everything is hooked up, the subscription's confirmed, so messages are going to be delivered. So what we're going to do here to test it out, we're just going to come to publish message. We're going to go to subject. This is totally optional. Payment here. So that's our subject, and say 1, 2, 3, 4, 5. Doesn't really matter here. Message attributes. So this is actually something that I did want to talk about because message attributes are a fantastic way of reducing cost on the side of, in this case, the Lambda, so the trigger. So let's actually, I want to talk about this for a few moments. So let's go back to our architecture diagram and talk and use this for reference. So in this kind of application, we have hypothetically transactions that are being pushed from clients into this topic. And transactions can be of multiple types. There can be maybe like a refund transaction, maybe it could be a purchase transaction. Say this Lambda function only cares about refunds. If we think about a normal kind of credit card application, like 99% of your transactions are probably just going to be normal purchases and not going to be refunds. So if you don't set up, in this case, attribute filtering, what will happen is you'd have to write code in this Lambda to say, if attribute type equals refund, then execute this code. Else, just return. So what does that mean for you? That means every single transaction you're going to be paying for because Lambda, remember, is costed on the number of invocations and the time per invocation and the memory. So, that's a complete waste of money. There's absolutely no point in having that. So what SNS filtering allows you to do, it allows you to define an attribute on the message from the push perspective. So the client that's pushing messages into the SNS can define an attribute that says, update type refund. And that can be passed along into the SNS topic. And then you can say, for this specific trigger, for this relationship, I only want to send refund notifications to the Lambda. So, if you have 100 total transactions and only one is a refund, instead of this being invoked 100 times, all of a sudden this is only going to get invoked one time. And the same holds true if you had a separate Lambda that really only cared about purchase transactions. So you would add a filter policy on the SNS topic for the client down here, so it would only get the purchase transactions. So this is a great way of kind of isolating your responsibility and reducing cost for yourself when setting this thing up. So coming back here, I'm actually not going to set this up right now because it's a whole kind of thing to do. So you can see here, you can define like kind of the content of your message attribute, the name of it, and kind of the type to filter on. We're not going to actually do this, so I'm just going to remove it. Okay, so I click publish message. So that message just got sent to the SNS topic, and going back here, I'm basically simulating this guy. I'm pushing the message into the SNS topic. And now, if we go to Lambda, and we come back here to payment processor, oops, and go to monitoring, there's our invocation right there, or right here. So this is your invocation. And that's basically it. I mean, you just wired this thing up from start to finish, and it was simple as hell. So these are kind of the metrics that you get by default on the Lambda dashboard. If you go to CloudWatch, you can actually find the name of the Lambda function and see all the corresponding logs. But yeah, let's actually do that now just to show you how I would kind of audit this. So I just went to CloudWatch from services here, CloudWatch. And then we're going into the log section. And whenever you create a Lambda function, by default, it creates a log group for you. So if I click on that log group, this is a log stream, which is basically like a slice of the data at a specific point in time. And then you can see here the function invocation. So this was the message that I put, if you recall, when I was publishing the message 1, 2, 3, 4, 5. And basically that is it. You have, in this example, pushed the message to an SNS topic that you've created. You've wired that up to a Lambda topic or to a Lambda handler and processed that message on the other side. So hopefully you found this video useful. Open to feedback, open to comments and questions. Let me know if you had trouble setting this up or if there's anything else you want to know. Yeah, thanks guys. Take care.